Okay, let's look at how to do a problem. It's a neutralization problem where we have an acid and a base that are combined together. So the first thing that you'd probably want to do is to figure out what you're mixing together. So we have HCl, okay, and we're titrating it with barium hydroxide. Now, I'm going to show you two ways to do this type of problem. So whenever you have an acid with an H in it, you can look at how many H pluses or H plus ions, how many hydrogen ions are in that acid versus how many hydroxide ions are in the base. But it has to be uh, H plus acid with an OH type of base to do it this way. So whenever you can see how many OHs are to how many H's in the problem, by looking at the subscripts right there, you can use this equation that goes N equals molarity acid volume acid equals N molarity base volume base. And then you just look at the N, which is 1 here, times the molarity of the acid, which we don't know, so we'll call that Ma, times the volume of the acid, which is 25.4 milliliters. That's going to be equal to the N for the base. Now, note that I'm looking at the subscript on the hydroxide. I haven't balanced the equation yet. So I'm looking at the subscript. So 2 times the molarity of the base, which is 0.75 molar. Oops, don't want that. So back to my pencil here. Okay, so that's 0.75 molar there. And the volume of the base is 74.3 milliliters. Now, one thing to be aware of, you want to make sure that these volume units match, milliliters, milliliters. You can't have 1 in liters and 1 in milliliters. Then you could do the math, and what you'll find out when you do that, it ends up that the molarity of the acid is around 4.4 molar, I believe. So now that's one way to do it, and that way is the fastest way when you have an acid with an H plus in it like this, that you can easily identify the number right here, and you have a base with an OH in it, and you can identify the subscript number there. All right. So like if it was like H3 something, then you would put a 3 right here. Okay, that's where the N's come in. But there is a different way to do it, and a lot of times you see people do it this way. Now this way is a little bit longer because what you need first is you need a balanced equation. So you'd have to take HCl plus BaOH2. Now, anyway, so what's going to happen is you're going to get barium chloride, BaCl2, plus water, H2O. You would balance that equation by putting a 2 here and a 2 here. Now this is using the stoichiometry way. So you know that you have 25.4 milliliters of this. You're trying to find the molarity of that acid. You know that you have 74.3 milliliters of the base, and you know the molarity of the base. So here's how you would start that problem. Whenever you have a volume like of the BaOH, so that's milliliters of BaOH, and you know the molarity of it, if you set up your picket fence just like this right away, and you put the molarity here, that's 0.75 moles over 1,000 milliliters, because capital M is moles for 1 liter or moles for 1,000 milliliters. If you do that math right there, you would automatically be in moles. Okay, if we stopped right there, the milliliters would cancel, we'd be in moles. But we don't want to stop there. Now we want to do the stoichiometry. Excuse me. So 1 mole of BaOH, I'm getting this from the balanced equation. Now with stoichiometry, remember you use the numbers in front. Okay, so 1 mole of BaOH to 2 moles HCl. Now, if I stop the problem right there, I'm going to be in moles of HCl. And if I do that and I do the calculator, I get 0.11145 moles of HCl. but I want the molarity of it. So I got to divide that. I got to divide that by how many milliliters I have, but actually it has to be changed to liters. So that's going to be 0.0254 liters is what that would be. And if you do that, you get the same answer, and you would end up getting 4.4 molar. All right, so I find that this top way here, this way is faster, and I believe it's easier, but you got to remember the ends are the numbers here, like H, how many H's, and how many hydroxides, not the coefficients from the balanced equation. It's a faster way to do it because you don't have to write a balanced equation, and I believe it's just easier. You're doing the same math. If you just look at it, you're doing pretty much the same math, but this way just makes it seems like it takes a little bit longer. Okay, but sometimes you don't have an H plus and an OH to do it. So here's another example where you can't do it like that, even though it's a neutralization problem. So we have some sulfuric acid, all right, and you spilled on the lab table, but you want to neutralize it with baking soda, which is sodium hydrogen carbonate or sodium bicarbonate. Now what that does, that's going to produce sodium sulfate plus CO2 gas plus water. Then you would have to balance that equation. It looks like we're going to need 2 sodiums. That gives me 2 carbons, so I'm going to put a 2 here. That gives me 2, 2, so I'm going to need 2 waters. Okay, that balances the equation. Now, you have 83.7 milliliters of the acid, and it's 3 molar strong. Okay, the question is how many grams of baking soda? Now, this problem, you can't quite do it like we did the other one because even though we have an H+, this baking soda is a base, but there's no OHs in it, so you can't do an MAVA type of thing. Anyway, we're not even looking for the molarity of anything because this is a solid, it's not a solution. So you got to do it a different way. You have to use stoichiometry. So here's the trick. Whenever you know a volume, okay, of something, and you know the molarity, if you set up your picket fence like this, and remember that molarity is moles for every 1,000 milliliters or moles per liter, you're automatically, if you do the math right there, the milliliters will cancel and you'll be in moles. But the question is how many grams of baking soda, so we're going to keep going. Now we're going to do the stoichiometry. For every 1 mole of H2SO4, you get 2 moles of the baking soda. But we want grams of baking soda, so we got to change moles of baking soda to grams. If I round it off a little bit, it's 84 grams is the molar mass. And then if you do all the math there, you end up getting about, let's see, what did I get for that? So I guess I get, if I round it off, about 42 grams of the baking soda that it would take. All right, that's it. When you look at these videos, make sure you go back and compare the answer, like how I did this neutralization kind of the faster way, and then how I did it the stoichiometry way. The biggest thing that I notice some students do is they confuse the two ways. You can do it either way, but make sure you don't confuse them. You might have to study this a little bit to make sure you don't confuse it. That's it.